Hello everyone, Dennis here. We have come to the last part of calculus, which is lesson 17, Kinematics. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Kinematics is all about the relationship between displacement, velocity, and acceleration. Let's look at the definition. 1. Velocity v. Velocity is the rate of change of displacement s. Based on what we have learned in the rate of change lesson, we know that v equals ds over dt. We can also find the s, which is the integration of v dt. 2. Acceleration a. Acceleration is the rate of change of velocity. So, it means that a equals dv over dt, or d square s over dt square. From here, we can find the velocity if we know the equation of the acceleration, which is v equals integration of a dt. So here we can find the relationship between s, v, and a. So s, if I have the equation of s, I can just differentiate the equation of s in terms of dt, which gets the equation of the velocity. Similarly, if we differentiate the equation of velocity, or d square s over dt square, we can get the equation of the acceleration a. If we do backwards, which means if we have the equation of the acceleration, we can integrate the acceleration and we get the equation of velocity. Similarly, if we integrate the equation of velocity, we will get the equation of the displacement s. There are a few common terms used in kinematics. Here are the terms. First, initial. When the movement is initial, then the time t equals 0. At rest. When an object is at rest, its velocity v equals 0. Stationary. When an object is stationary, similar with at rest, the velocity is equal 0. Particle is at fixed position. When a particle is at fixed position, the displacement s equals 0. Maximum or minimum displacement. It means that v equals 0 because ds over dt equals 0. Similarly, maximum or minimum velocity, the acceleration equals 0 because when velocity is maximum or minimum, dv over dt equals 0. Average speed. When we want to find average speed, there is a formula which is average speed equals total distance traveled over total time taken. Please remember all these common terms used in kinematics. Now, let's talk about the concept of velocity as a vector quantity. If you study physics, you should learn this concept more in detail. Vector is a vector quantity, which means that its sign shows direction. In general, when a particle travels, here is the particle. If it moves from left to right, the velocity is positive. So velocity is positive. When it moves from right to the left, which is in this case, then the velocity is negative. So velocity is negative. And next, if it moves from bottom to the top, the velocity is, maybe you think about positive, but usually we assume that it is negative. So the velocity is negative when it moves from bottom to top. On the opposite direction, where the particle travels from top to bottom, then the velocity is positive. Now, you might ask, why is it so? Usually, we follow the direction of gravitational pull force. When we move from bottom to top, then we'll assume that the velocity is negative, as usually it will move slower. When it moves from the top to the bottom, it is moving towards the direction of the gravitational pull force. Therefore, it will move faster and faster, and we assume that velocity is positive. Unless it is otherwise mentioned in the question. When an object moves, it may change its direction. However, there are some conditions must be met before a moving object can change its direction. Let's look at this situation. This is a ball, and it is thrown outwards. As it moves outwards, it decelerates at constant rate. This is because it moves against the direction of the gravitational pull force. The velocity reduces over the time as it decelerates. Until what point? When the ball reaches its maximum height, then the velocity becomes 0. At this point, the ball changes direction and starts to fall downwards. The ball now moves in the opposite direction, which means that the sign of velocity changes. Here is some conclusions that we can make. Number 1. The velocity of a particle needs to reduce to 0 before it can change direction. 2. Negative velocity does not mean the particle slows down. It shows that the current direction of motion of the particle opposes its reference direction. Now, let's talk about the difference between distance and displacement. Distance is a scalar quantity, while displacement is a vector quantity. Distance is the total length traveled throughout the whole journey. It does not consider direction. On the other hand, displacement is the total length measured from a reference point. Usually, this reference point is the starting point, unless otherwise stated. Displacement indicates the position of the moving object from the reference point at a certain time. Negative displacement indicates that the object is at the opposite side of the reference point. How are we going to calculate the total distance traveled if we know the displacement? Here are a few steps. To find the total distance traveled in a given period of time, where time is from 0 to t2, we need to determine if the moving particle changes its direction or not by letting v equals 0, then find the time when it stops. If the time t equals to t1 that it stops is within the given period of time, which means t1 is less than t2, then we need to calculate the displacement as 1, which is measured from its starting point O to its position when t equals t1. Then calculate the displacement S2, which shows its distance measured from the starting point O. It is always a good idea to sketch the path of the movement to see the whole picture so that we can calculate the total distance traveled correctly. Here is an example. Let's say this is the reference point, point O. At time equals 0, the moving object is at this point, and it starts to move at this direction until it reaches this point with the displacement S1 at the time t equals to t1. At this point, its velocity equals 0, and it starts to turn or change direction. And it will move in this way until at this point at displacement S2, which is measured from the reference point, point O, at the time t equals t2. So now, the total distance traveled, it can be split into two parts. The first part will be S1, and the second part is S1 minus S2. Hence, the total distance traveled equals S1 plus S1 minus S2. Now, let's look at this example, which is related to velocity as the rate of change of displacement. Here is the question. A particle moves in a straight line such that t seconds after passing through a fixed point O, its displacement is s meters. Given that x equals 10 minus 4 over t plus 1, find 1. Expressions in terms of t for the velocity and acceleration of the particle. 2. The value of t when the velocity of the particle is 0.25 meters per second. 3. The acceleration of the particle when it is 8 meters from O. So, here's the solution. Let's look at this question. The equation given is the equation of the displacement s. Therefore, given that s equals 10 minus 4 times t plus 1 to the power of negative 1, so we put it into indices form first, so that to find the expression of the velocity v, it is equals ds over dt, and we can differentiate the equation easily. We get differentiate 10, we get 0. Then we differentiate minus 4 times t plus 1 to the power of negative 1, we get 4 times t plus 1 to the power of negative 2. And put it back into fraction, we get v equals 4 over t plus 1 squared. To get the expression for acceleration, it is equals dv over dt. We will use this as the equation of the velocity, and when we differentiate it, we get negative 8 over t plus 1 cubed. For 2, given that the velocity is 0.25, we just need to substitute 0.25 into the equation of the velocity, which becomes 0.25 equals 4 over t plus 1 squared. And we solve this equation, t plus 1 squared equals 4 over 0.25. So t plus 1 equals 4, or t plus 1 equals negative 4. T equals to 3 seconds, or t equals to negative 5. We reject the negative value as the time is always positive. 3. Acceleration when it is 8 meters from O, which means that s equals 8. So we substitute s equals 8 into the displacement equation so that we can find the time. So it is 8 equals 10 minus 4 over t plus 1. We solve this equation. 4 over t plus 1 equals to 2. T plus 1 equals to 2. T equals to 1. So when t equals to 1, we substitute it into the equation of the acceleration, which becomes negative 8 over 1 plus 1 cubed, and we get A is negative 1 meters per second square. Now you can try this example yourself. A particle moves in a straight line such that its displacement s meters from a fixed point O on the line is given by s equals t cubed plus half t squared minus 4t plus 5, where t is the time in seconds after passing a point A on the line. Find 1. The distance OA. 2. The values of t when the particle is instantaneously at rest. 3. The initial acceleration of the particle. 4. The total distance traveled by the particle in the period from t equals to 0 to t equals to 2. You can pause the video and try to solve it yourself. Here is the solution. So this question, we have the equation of the displacement s equals t cubed plus half t squared minus 4t plus 5. So for part 1, when the particle passing point A, the time is 0. So we can substitute t equal to 0 into the equation of the displacement. Hence it becomes s equals 0 cubed plus half times 0 squared minus 4 times 0 plus 5. And we get s equals 5 meters, and this is the distance of OA. For part 2, before we want to find the t, we need to know the equation of the velocity, which is v equals ds over dt. We need to differentiate the equation of the displacement, this. And we get v equals 3t squared plus t minus 4. So it is at instantaneously at rest, hence v equals 0. The equation becomes 0 equals 3t squared plus t minus 4. And we solve this equation. First, we factorize, we get 0 equals t minus 1 times 3t plus 4. Hence, t equals to 1 second, or t equals to negative 4 over 3. And we reject the negative value as the time is always positive. For part 3, we need to find the equation of the acceleration, which is a equals dv over dt, which means that we need to differentiate the equation of the velocity, which we get a equals 60 plus 1. So when it is initial, the time is 0. So we substitute t equal to 0 into the equation of the acceleration, which is a equals 6 times 0 plus 1, and we get 1 meters per second squared. Here is the solution for number 4. The total distance traveled by the particle from period t equals to 0 to t equals to 2. So now we know that when t equals 1, s1 equals 1 cubed plus half times 1 squared minus 4 times 1 plus 5. So this is the time when it is instantaneously at rest. And we get the displacement is 2.5 meters. When time is 2, then s2 equals 2 cubed plus half times 2 squared minus 4 times 2 plus 5, which gives us 7 meters. And now we can sketch the diagram. This is the reference point O. When t equals to 0, it starts at point A, which is 5 meters from O. and it moves towards the O, and when t equals to 1, its displacement is at 2.5 meters. So this is the particle. And after t equals to 1, it changes direction to t2, which is the displacement is at 7 meters, and we get to this point. So the total distance that it has traveled is 4.5 meters. Hence, to find the total distance, it is 2.5 meters plus 4.5 meters, which is 7 meters. Now, let's look at the example for the equation of the velocity is known. Here is the example. A particle moves in a straight line such that t seconds after passing a fixed point O, its velocity is v meters per second. Given that v equals t squared plus 5t minus 6, find number 1, the initial acceleration of the particle. 2, the value of t for which the particle is instantaneously at rest. 3, the distance of the particle from O when t equals 4. 4, the total distance traveled in the first 4 seconds. 5, the average speed of the particle during the first 4 seconds. Here is the solution. So for this example, we know the equation of the velocity, which is v equals t squared plus 5t minus 6. So for part 1, given that v equals t squared plus 5t minus 6, we want to find the acceleration, which is dv over dt, and we get 2t plus 5. So in initial acceleration, the t is 0, hence acceleration will be 2 times 0 plus 5, which gives us 5 meters per second squared. 2, the value of t for which the particle is instantaneously at rest. So when it is instantaneously at rest, the v is 0. Hence the equation becomes 0 equals t squared plus 5t minus 6, which we get from the equation of the velocity. We solve this equation by factorizing it. So 0 equals t plus 6 times t minus 1. So t plus 6 equals 0, or t minus 1 equals 0. Hence t equals negative 6, or t equals to 1. You reject the negative value as the time is always positive. Hence, we can say that the particle is instantaneously at rest when t equals 1 second. Part 3, the distance of the particle from O when t is 4. So, we want to find the equation of the displacement, which is s equals integration of v dx v dt. So we get integration of t squared plus 5t minus 6 dt. And we get t cubed over 3 plus 5t squared over 2 minus 6t plus c. When t equal to 0, s is 0. As mentioned in the question, it passes the fixed point O initially. So c will be 0. Therefore, the equation of the displacement will be s equals t cubed over 3 plus 5t squared over 2 minus 6t. When t equals 4, then the displacement will be 4 cubed over 3 plus 5 times 4 squared over 2 minus 6 times 4, which gives us 37 and 1/3 meters. So this is the displacement, or the distance of the particle from O when t equals to 4. Here is the solution for part 4. To find the total distance traveled in the first 4 seconds, first we need to know when the particle changes its direction. So the particle changes its direction at t equals to 1. Because in the previous calculation, we know that the particle is instantaneously at rest when t equals to 1. So we want to find the displacement, which is s equals 1 cubed over 3 plus 5 times 1 square over 2 minus 6 times 1. We get negative 3 and 1 over 6 meters. Also from the previous calculation, which is from the part 3, we know that when t equals to 4, the displacement is 37 and 1/3 meters. Using this information, we can start to sketch the diagram. So this is the reference point O. At time equals to 0, the particle is at this point. When time is equals to 1, the displacement is at negative 3 and 1 over 6, which means it moves at this direction and stops at this point. Then it changes its direction and move to t equals to 4 at 37 and 1/3 meters. It stops at this point. So from here, we can calculate the total distance traveled, which is d equals 2 times of 3 and 1 over 6 meters plus 37 and 1/3 meters, which gives us 43 and 2 over 3 meters. Number 5, to find the average speed, we just apply the formula, which is the total distance traveled over the total time taken, and we substitute the values, which is 43 and 2 over 3 meters divided by 4 seconds. The answer is 10 and 11 over 12 meters per second. Now you can try this example yourself. A particle moves in a straight line such that t seconds after passing a fixed point O, its velocity is v meters per second. Given that v equals 5 plus 4t minus t squared, find 1. The value of t when the acceleration of the particle is 1 meter per second squared. 2. The value of t when the particle is instantaneously at rest. 3. The maximum speed of the particle. 4. An expression in terms of t for the displacement of the particle from O at time t. 5. The distance traveled in the 6th second. 6. The total distance traveled in the first 6 seconds. You can pause the video and try to solve it yourself. Here is the solution. For part 1, given that the equation of the velocity of the particle is v equals 5 plus 4t minus t squared. Before we want to answer the question, we need to find the equation of the acceleration of the particle, which is a equals dv over dt, and we get the equation is a equals 4 minus 2t. So when a equals 1 meter per second square, then the equation becomes 1 equals 4 minus 2t. Now we solve this equation, we get t equals 3 over 2 seconds. Part 2, the value of the t when the particle is instantaneously at rest. When it is at rest, it means v equals 0. Hence, the equation of the velocity becomes 0 equals 5 plus 4t minus t squared. And now we can solve this equation. First, we make t squared minus 4t minus 5 equal to 0. Then we factorize, we get t plus 1 times t minus 5 equals to 0. T plus 1 equals to 0, or t minus 5 equals to 0. Hence, t equals to negative 1, t equals to 5. We reject t equals to negative 1 because t is always positive. Therefore, the particle is instantaneously at rest when t equals 5 seconds. Here is the solution for part 3, the maximum speed. Maximum speed, which means dv over dt, equals 0. Therefore, 4 minus 2t equals to 0, and we solve this equation, we get t equals 2 seconds. Hence, maximum speed Vmax equals 5 plus 4 times 2 minus 2 square, which gives us 9 meters per second. Number 4, the expression of the displacement, we need to integrate the equation of the velocity. Hence, s equals integration of v dt, which is integration of 5 plus 4t minus t squared dt, which we get the equation of the velocity given here. Therefore, we get 5t plus 2t squared minus t cubed over 3 plus c. So when t equals to 0, the s equals to 0, as it is mentioned in the question. Initially, it passes through the fixed point O, so s is 0. Therefore, c is 0. Hence, we can rewrite the equation of the displacement as equals 5t plus 2t squared minus t cubed over 3. Solution for number 5. The distance traveled in the 6th second. So we need to find when t equals to 6, s equals 5 times 6 plus 2 times 6 squared minus 6 cubed over 3, which gives us s equals 30 meters. So this shows the position of the particle, which is 30 meters away from the fixed position O. When t equals to 5, the displacement is 5 times 5 plus 2 times 5 squared minus 5 cubed over 3, which gives us 33 and 1/3 meters, which shows the position of the particles from the fixed point O, which is 33.1/3 meters. To illustrate, here is how it looks like. This is the fixed position O. At the time equals 5 seconds, the displacement is 33.1/3 meters, and the particle is at this point. It moves at this direction, and when the time is 6 seconds, the displacement is 30 meters, and the particle is at this position. Therefore, the distance traveled in the 6th second equals 33 and 1/3 minus 30, which gives us 3 and 1/3 meters. Number 6, total distance traveled in the first 6 seconds. So we need to find the displacement for important times. The first one is when t equals to 0, we know that the displacement is 0 meters. When t equals to 5, the displacement is 33 and 1/3 meters, which at this point, the particle changed its direction. When t equals to 6, the displacement is 30 meters. To illustrate the whole journey, here is how it looks like. This is the fixed position O. When the time is 0, the particle is at this position. Then it moves at this direction, and until when the time is 5 seconds, the displacement is 33 and 1/3 meters, and the particle is at this position. And at this time, it changes its direction and moves towards this direction. When the time is 6 seconds, the displacement is 30 meters and the particle is at this point. So now, based on this diagram, we can find the total distance traveled, which is 33 and 1/3 meters plus 3 and 1/3 meters. So from here to here, this distance is 33 and 1/3. And from here to here, this distance is 3 and 1/3. Therefore, the total distance traveled is 36 and 2/3 meters. Next, we want to talk about the example where the equation of acceleration is known. Here is the example. A stationary particle moves in a straight line such that t seconds after passing a fixed point O, its acceleration is a meters per second square. Given that a equals 2 cosine t minus sine t, find 1. The value of t when the particle first comes to an instantaneous rest. 2. The distance traveled by the particle in the first 30 seconds after passing through O. Here is the solution. As I mentioned just now, the equation of the acceleration is given, which is a equals cosine t, 2 cosine t minus sine t. So before, now, given that a is 2 cosine t minus sine t, so we want to find the equation of the velocity, which is v equals integration of a dt equals integration of 2 cosine t minus sine t, and we get 2 sine t plus cosine t plus c. So when t equals to 0, v equals to 0, because the question mentioned it is stationary at the beginning. Hence, we can substitute t equals to 0 into the equation, which becomes 0 equals 2 sine 0 plus cosine 0 plus c. Sine 0 is 0, but remember, cosine 0 is not 0, it is equals 1. Therefore, c is negative 1. Therefore, the equation of the velocity will be equals 2 sine t plus cosine t minus 1. When it is instantaneous at rest, v equals to 0. Therefore, 0 equals 2 sine t plus cosine t minus 1, which means 2 sine t plus cosine t equals to 1. Now, to solve this equation, we can apply the R formula, where a is 2, b is 1. Therefore, R equals square root of 2 square plus 1 square, which gives us 35. For alpha, it is equals inverse of tangent 1 over 2, which is 0.46365. Over here, do take note that I would highly recommend you to leave the angle in radian mode for calculation in kinematics. Now we can rewrite the equation into the R formula form, which gives us 35 sine t plus 0.46365 equals 1. So sine t plus 0.46365 equals 1 over 5. We can solve this equation by finding the base angle alpha, which gives us 0.46365. Sine is positive, so the angle is in the first and the second quadrant. Therefore, t plus 0.46365 equals 0.46365 and pi minus 0.46365, which means that t equal to 0 or t equals to 2.2143. We leave the answer in 5 significant figures. From here, we can say that the particle first comes to an instantaneous rest when t equals 2.21 seconds, where we leave the answer in 3 single figures. We don't take t equals to 0 as this is the initial point or initial time when the particle starts moving. Here is the solution for part 2. To find the distance traveled, we need to find the equation of the displacement, which is s equals integration of v dt. So it is integration of 2 sine t plus cosine t minus 1 dt. And we get s equals negative 2 cosine t plus sine t minus t plus d. Now we want to find the constant d. When t equal to 0, the s equal to 0 because it is passing the fixed point O when it first start the journey. Mentioned here. So don't forget to substitute t0 and s is 0 into the equation before making conclusion that d equal to 0 because this case d is not equal to 0. So we get this 0 equals to negative 2 cosine 0 plus sine 0 minus 0 plus d. Remember, cosine 0 is 1. The rest is 0. Hence, d is equals 2. Therefore, s is negative 2 cosine t plus sine t minus t plus 2. When t is 2.2143, so this is the time when it comes to instantaneous rest, which means it changed direction. So the displacement will be s equals negative 2 cosine 2.2143 plus sine 2.2143 minus 2.2143 plus 2. And we get s equals 1.7857. We leave it as 5 significant figures. And at this point, it changed its direction. So when t equals to 3, then s equals negative 2 cosine 3 plus sine 3 minus 3 plus 2, and we get s equals 1.1211. Remember, when you want to press calculator, make sure that you set the setting in your calculator correctly where the angle is in radian mode. So the s is 1.1211, we leave it in 5 significant figures. And now we can sketch the diagram when this is the reference point O. At the time equal to 0, the particles start at this point. And it moves in this direction until when time is 2.2143 seconds, the displacement is 1.7857 meters, the particle is at this point. Then it changes direction until when t equal to 3 seconds, the displacement is 1.1211 meters, and this is the particle. So the total distance traveled will be 1.7857 plus 1.7857 minus 1.1211, which gives us 2.45 meters. Now you can try this example yourself. A particle P moving in a straight line passes a fixed point O with a speed of 9 meters per second. Its acceleration is a meters per second squared. Given that a equals k e to the power of 2t, where k is a constant, the particle comes to instantaneous rest at t equals half ln phi/2. 1. Find the value of k. 2. Find an expression in terms of t for the displacement of the particle p from O at time t seconds. 3. Find the total distance traveled by the particle when it next returns to O. You can pause the video and try to solve it yourself. So here's the solution for part 1. Given that a equals k times e to the power of 2t, so we want to find the velocity, the equation of velocity first, which is v equals to integration of a dt or integration of k e to the power of 2t dt, and we get v equals to k over 2 e to the power 2t plus c. Given that the initial speed is 9 meters per second, which means that when t equals to 0, v is 9. Substitute the values inside the equation, we get 9 equals k over 2 plus c. And we get that c equals 9 minus k over 2. Hence, we can rewrite the equation v equals k over 2 e to the power 2t plus 9 minus k over 2. So, the next information given is that the particle is at instantaneous rest when the time is half ln phi over 2, which means that v equals to 0 when the time is half ln phi over 2. So we substitute all the values into the equation, we get 0 equals k over 2 times e to the power 2 times half ln phi over 2 plus 9 minus k over 2, which is k over 2 e to the power ln 5 over 2 equals k over 2 minus 9. So e to the power ln 5 over 2 gives us 5 over 2. And we get k over 2 times 5 over 2 equals k over 2 minus 9. Which is 5 over 4k equals k over 2 minus 9. Or 3 over 4k equals negative 9. And k is negative 12. So this is the answer for part 1. For part 2, now we want to find the displacement. The equation of the displacement, so k is negative 12, we find the value of c, which is 9 minus negative 12 over 2, and the answer is 15. So we can rewrite the equation of the velocity, which is v equals negative 6 times e to the power 2t plus 15. And to get the equation of the displacement, it is the integration of v dt, which is integration of negative 6 e to the power 2t plus 15 dt. And we get negative 6 e to the power 2t over 2 plus 15t plus d. Simplify, we get s equals negative 3 e to the power 2t plus 15t plus d. So when t equals to 0, the displacement is 0. As mentioned in the question, it passes the fixed position or fixed point O initially. Hence, substitute the value inside. 0 equals negative 3 e to the power 2 times 0 plus 15 times 0 plus d. Remember, e to the power 0 is not 0, but it is 1. Therefore, d is equals 3. Then we can rewrite the equation as equals negative 3 e to the power 2t plus 15t plus 3. Here is the solution for part 3. To find the total distance traveled by the particle when it next returns to O. So S is negative 3 e to the power 2t plus 15t plus 3. We know that when t equals half ln phi over 2, it is instantaneous at rest, which means it's changed the direction. Therefore, we can get the displacement at this time, which is s equals negative 3 e to the power 2 times half ln phi over 2 plus 15 times half ln phi over 2 plus 3. So we simplify, we get negative 3 e to the power ln phi over 2 plus 15 times half ln phi over 2 plus 3, or equals negative 3 times phi over 2 plus 15 times half ln phi over 2 plus 3, as we know that e to the power ln phi over 2 is phi over 2. The rest we just copy. And then we just press calculator. The value of s is 2.3722. We can leave it as 5 significant figures. Now we can start to draw the diagram. This is the reference point or the fixed point O. When t equals to 0, the particle is at this point. It moves at this direction. At time is half ln phi over 2. The displacement is 2.3722 meters, and the particle is at this point. And it starts to change its direction as it is at instantaneous rest. And it goes back to the original fixed point O, which is required by the question, returns to O. and we reach here. So the total distance traveled will be 2 times of 2.3722, which gives us 4.74 meters. We leave it as 3 single figures. Okay, now let's talk about problems involving two moving particles. So far, we only talk about one moving particle. So here's an example. Two particles A and B leave a fixed point O at the same time and travel in the same direction along the same straight line. Particle A starts with a velocity 1 meters per second and moves with a constant acceleration of 1.5 meters per second square. Particle B starts from rest and moves with an acceleration of a meters per second square, where a equals 1 plus t over 6 and t seconds is the time since leaving O. Find 1. The velocity of each particle in terms of t. 2. The distance traveled by each particle in terms of t. And hence, find 3. The time when B collides with A. 4. The speed of each particle during the collision. Here's a solution. Let's look at this question. It is given the equation of the acceleration for particle B and particle A. It moves at constant acceleration 1.5 meters per second square. Right? So from here, part 1, to find the velocity, it is an integration of A dt. Hence, the velocity of particle A, it is integration of 1.5 dt, since it is constant acceleration, which we get VA equals 1.5 t plus C1. And given from the question, when t equals to 0, the velocity is 1 meters per second. Therefore, substitute it into the equation, we get C1 is 1. So VA equals 1.5 t plus 1. Next, to find the velocity of B, it is integration of 1 plus t over 6 dt, which is the equation of the acceleration. And we get VB equals t plus t squared over 12 plus C2. And given that when t equals to 0, VB is 0, because it says that starts from rest. Hence, C2 is 0. Therefore, the equation of velocity of particle B equals t plus t squared over 12. Part 2. To find the distance, first we need to know the equation of the displacement first, which is S equals integration of V dt. So, the displacement for particle A equals integration of 1.5 t plus 1 dt, which gives us SA equals 1.5 t squared over 2 plus t plus d1. Simplifying, we get SA equals 3 over 4 t squared plus t plus d1. And when t equals to 0, SA is 0. Okay, because both of the particles leave a fixed point O at the beginning. So d1 equals to 0. Hence, SI equals 3 over 4 t squared plus t. To find SB, it is the integration of t plus t squared over 12 dt, which is the equation of the velocity of the particle B. And we get SB equals t squared over 2 plus t cubed over 36 plus d2. So similar with the particle A, when t equals to 0, displacement of B is 0. Hence, d2 is 0. Therefore, the equation of the displacement for particle B, SB, equals t squared over 2 plus t cubed over 36. Solution for part 3. When they collide, SA must be equals to SB, which means 3 over 4 t squared plus t equals t squared over 2 plus t cubed over 36. Now we can solve this equation. So 0 equals t cubed over 36 plus t squared over 2 minus 3 over 4 t squared minus 2 minus t, which is 0 equals t cubed over 36 minus 1 over 4 t squared minus t. And we times 36 for both sides, we get 0 equals t cubed minus 9t squared minus 36. Then we factorize t, which gives us 0 equals t times t squared minus 9t minus 36. Then we factorize, we get t 0 equals t times t plus 3 times t minus 12. So t equals to 0, or t equals to negative 3, or t equals to 12. Alright, so we reject the t equals to negative 3 as t is always positive. Then we can say that B collides with A 12 seconds after leaving point O. Lastly, here is the solution for part 4. When the particles collide, we know that the time is 12. Now we can find the speed of each particle by substituting t equals to 12 into the equation of their velocity. Hence, for VA is 1.5t plus 1, which is 1.5 times 12 plus 1, and gives us 19 meters per second. For the velocity of B, it is VB equals t plus t squared over 12. So substitute t equals to 12 inside. We get VB equals 12 plus 12 squared over 12, and we get 24 meters per second. This is the answers for part 4. Now, you can try this similar example yourself. Two particles A and B leave a fixed point O at the same time and travel in the same direction along the same straight line. Particle A passes point O with a velocity of 2 meters per second and travels with a constant acceleration of 1.5 meters per second squared. Particle B starts from rest, and its acceleration, a meters per second squared, is given by a equals 8 minus t, where t is the time in seconds after passing O. Find 1. The velocity of each particle in terms of t. 2. The time when particle B is instantaneously at rest. 3. The time when the particles first meet after leaving O. You can pause the video and try to solve it yourself. Here is the solution. For part 1, to find the equation of the velocity, we need to integrate the equation of acceleration. So V equals integration of A dt. So for VA, it is integration of 1.5 dt, because in the question, it mentioned that the particle A accelerates at a constant rate of 1.5 meters per second squared. Therefore, it is integration of 1.5 dt. Hence, VA will be 1.5 t plus C1. When t equals to 0, VA is equals to, as mentioned in the question, the velocity is 2 meters per second initially. Hence, C1 equals to 2. So we can rewrite the equation for the velocity of particle A, which is VA equals 1.5 t plus 2. For VB, it is integration of 8 minus t dt, because the equation of the acceleration given is 8 minus t. When we integrate, we get VB equals 8t minus t squared over 2 plus C2. So when t equals to 0, VB equals to 0. As mentioned in the question, particle B starts from rest. The word the rest means V is 0. Therefore, C2 is 0. Hence, VB equals 8t minus t squared over 2. The solution for part 2, the time where particle B is instantaneously at rest. So when it is instantaneous at rest, which means VB equals to 0. Hence, 0 equals 8t minus t squared over 2, which is the equation of VB. So, t squared over 2 minus 8t equals to 0. So, we multiply by 2, we get t squared minus 16t equal to 0. Factorize the t, so t times t minus 16 equal to 0, t equal to 0, or t equal to 16. Hence, particle B is instantaneously at rest 16 seconds after leaving point O. For solution part 3, before we want to answer the question, we need to find the equation of the displacement for each particle. Hence, S equals integration of V dt. For the equation of displacement of particle A, SA, it is equals integration of 1.5t plus 2 dt, which gives us SA equals to 1.5t squared over 2 plus 2t plus t1. And we simplify it, we get SA equals 3 over 4 t squared plus 2t plus t1. So when t equal to 0, SA equal to 0, because it's both the particles leaves the fixed point O initially. Hence, d1 is 0. Therefore, SA equals to 3 over 4 t squared plus 2t. To find the equation of displacement of particle B, SB, it is equals integration of 8t minus t squared over 2 dt, which gives us SB equals 4t squared minus t cubed over 6 plus d2. So when t equal to 0, similar with SA, SB equals to 0. Therefore, d2 is 0. As I mentioned just now, both particles leave the fixed point O initially. Hence, SB equals 4t squared minus t cubed over 6. Now, we already know the equation of displacement for both particles. Now, let's answer the question. When the particles meet, SA equals SB, which means that 3 over 4 3 squared t squared plus 2t equals 4t squared minus t cubed over 6. Now we can start to solve this equation. So I just want to make the t cubed to be positive, so it becomes t cubed over 6 plus 3 over 4 t squared minus 4t squared plus 2t equals to 0. Simplify, we get t cubed over 6 minus 13 over 4 t squared plus 2t equals to 0. Then I multiply 12 for both sides. I get 2t cubed minus 39t squared plus 24 t equals to 0. Then I factorize the t. So t times 2t squared minus 39t plus 24 equals to 0. Hence, t equal to 0 or 2t squared minus 39t plus 24 equals to 0. And for this equation, we can't really factorize directly. So to solve this equation, we have to use the formula method, which is the t equals negative b plus minus square root of b squared minus 4ac over 2a. So for this case, the a is 2, b is negative 39, and c is 24. Hence, t equals negative bracket negative 39 plus minus square root of negative 39 squared minus 4 times 2 times 24 over 2 times 2. And I press calculator, I get t equals to 18.9 or t equals to 0.3636, which means both particles meet each other at 2 times. The first time is t equals to 0.636 and the second time is 18.9 seconds. Of course, when t equals to 0, this is the starting point. Both of the particles leave the fixed point O at the same time at the beginning. So, to answer the question, I leave the answer in 3SF. To answer the question, the particles first meet when t equals 0.636 seconds. Do you get all the answers correctly? Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.